Hi everybody. So in this video, we're going to look at an example that involves problem solving with a binomial expansion. We've been asked to expand 1 minus 3x to a power of 1/5 in ascending powers of x up to the x squared term. And we can see that we have this constant of 1. So the power will be this 1/5, and the x term will map onto the negative 3x. So now we just need to substitute each of these into this expansion form. So 1 minus 3x to a power of 1/5 will be approximately the 1 plus nx, and n is 1/5. X maps onto negative 3x, and then plus the n times n minus 1. So 1/5 multiplied by negative 4/5. And then the x squared term will be the negative 3x term squared divided by the 2 factorial, which is just 2. We don't need to go any further because we've only won the x squared term. So now we can tidy this up. This will be 1. For the x term, we'll get negative 3/5. And then for the x squared term, I can work this out on my calculator. We'll have 1/5 multiplied by the negative 4/5 multiplied by the negative 3 squared, all divided by 2. And this will give us negative 18x squared over 25. Okay? So this is the expansion. And for part B, by substituting x equals 1/32, find an approximation to the fifth root of 29. So you can see we're looking at the fifth root, and we have the same here. The power of 1/5 is the same as the fifth root. So if we substitute in 1/32 into this x, then we'll get 1 minus 3/32 raised to a power of 1/5. And this 1 is the same as 32/32. And when you raise this to a power of 1/5, you can see we get 32 minus 3, which is the 29/32 to a power of 1/5. And then if we take the fifth root of the numerator and denominator, we get the fifth root of 29 divided by the fifth root of 32, which is 2. And we know that this will be equal to our expansion. So we just need to substitute in 1/32 into the x term and the x squared term. So we'll have 1 minus 0.6 times 1/32 minus 18/25 multiplied by 1/32 squared. And this is approximately 0.9805. So now all we need to do is to multiply both sides by the 2, and we'll get the fifth root of 29. So the fifth root of 29 will be the 0.9805 times 2, and this is 1.961. And we can check the accuracy of this. If we enter 29 and we raise it to a power of 1/5, you can see that we're correct to 3 decimal places. Okay? In the next video, we're going to look at a different problem-solving type question with a binomial expansion. In our next example, we've been asked to write 5/3 minus 2x minus 1/4 minus 3x as a power series up to the x squared term. So if we work out the first one in green and the next one in purple, then we'll begin with 5/3 minus 2x. Well, the first thing we can do is we can write this denominator as a power to -1, and we can factor out this 3. So this will be the same as 5 lots of 3 multiplied by 1 minus 2/3 x. And this is raised to a power of -1. Then we can expand out this -1. So we'll get 5 multiplied by 1/3, or 5/3, multiplied by 1 minus 2/3 x to a power of -1. So then we can apply the binomial expansion to this part here. We know the n term will be the power of -1, and the x term will map onto the -2/3 x. So we just need to substitute each of these into our expansion. So 5/3 minus 2x will be approximately 5/3 of the 1 plus n times x, so -1 times -2/3 x, plus the n minus 1, and the x term squared, so -2/3 x squared, divided by the 2 factorial, which is 2. And we only need to do up to the x squared term. So now we can tidy this up. This will be approximately 5/3. We'll have the -1 times the -2/3, so positive 2/3 x. And then you can see in this positive 2 will cancel with this division of 2. So we're left with -2/3 squared. And this will give us 4/9 x squared. Okay? And then we'll expand out this bracket. So we'll get approximately 5/3. 5/3 times the 2/3 will give us 10/9 of x. And then we'll have the 5/3 times the 4/9, and we'll get 20/27 x squared. So this is for this fraction. Now we need to do the same again for the second purple fraction. So do you want to give this question a go yourself, writing this as a power series? You can pause the video and come back when you're ready. Okay, so how did you get on with that? We have 1/4 minus 3x. And we need this to be a power, and we need to factor out the 4 to give us the constant of 1. So we'll have 1 multiplied by the 4 times 1 minus 3/4x, all raised to a power of -1. Then we'll expand out this power of -1. So we'll get 1/4 to the -1, or 1/4, multiplied by 1 minus 3/4 of x, and at -1. So then you can see that n will be the power -1, and the x term will map on to -3/4x. And then we just need to substitute each of these into here. So we'll have 1/4 minus 3x will be approximately 1/4 multiplied by the 1 term plus n times x. And then the x squared term, so n minus 1, and the x term squared, divided by the 2. Okay? We'll tidy up this bracket, so we'll get approximately 1/4 multiplied by the 1. We'll get positive 3/4x here. And then this positive 2 will cancel with this division of 2. So we've got -3/4 squared. And this will give us 9/16 x squared. And then we'll expand out the quarter, so we get approximately 1/4 plus a quarter times the 3/4 will give us 3/16. And then a quarter times 9/16 will give us 9/64. Okay? So we've got the expansion for the first fraction and the second one. Now we just need to have the green expansion take away the purple expansion. So f of x will be the green one take away the purple one. And I'll just put this in brackets to make sure. So now f of x will be the 5/3 take away the 1/4, which is 17/12. The 10/9 take away the 3/16, which is 133 over 144 x. And then the 20/27 x squared minus the 9/64 x squared, which is 1037 over 1728 x squared. Okay? So that's your expansion for f of x. And then for part B, state the range of values of x for which the expansion is valid. So we know that the modulus of x has to be less than 1 for the expansion to be valid. The problem we have is that we've got two x terms. We've got the one for the green fraction and the one for the purple fraction. And we need the modulus of each of these to be less than 1. So if we begin with our green fraction, the modulus of -2/3 x has to be less than 1, then the modulus of the x term will be less than 3/2. And if we look at our purple fraction, the modulus of -3x/4 has to be less than 1, then the modulus of x has to be less than 4/3. But now we need to look at which one we have to use. Well, if we sketch both of them on a number line, we can see we'll include 0. We've got 3/2 and -3/2. So this will be for our green fraction. And then we'll have 4/3. So this will be for our purple fraction. And this should be a negative here. So the range for our values of x should be from -4/3 to +4/3. Because if we go beyond that, these values of x will not be valid for our purple fraction. Okay? So the expansion is valid when the magnitude of x is less than 4/3. Okay? If you need more practice on this, you can download the worksheet or check out the online lesson on my website.